Hello students, let's continue our topic. Show that any odd positive integer is of the form 6q plus 1 or 6q plus 3 or 6q plus 5 where q is some integer. Solution. Let a be any positive integer and b is equal to 6. Then by Euclid's algorithm a is equal to 6q plus r while q is greater or equal to 0. If our remainder is equal to 0 then a is equal to 6q. If our remainder is equal to 1, then a is equal to 6q plus 1. If r is 2, then a is equal to 6q plus 2. If r is 3, then a is equal to 6q plus 3. If r is 4, then a is equal to 6q plus 4. And if r is 5, then a is equal to 6q plus 5. Since 6q plus 2, 6q plus 4 are divisible by 2, thus when a is odd, it is in the form of 6q plus 1, 6q plus 3 or 6q plus 5 for some integer q. Next question. Show that any positive integer is of the form 3q or 3q plus 1 or 3q plus 2 for some integer q. Solution. Let a be any positive integer and b is equal to 3. This time we will take b as 3 because it is in the form of 3q or 3q plus 1 or 3q plus 2. That's why we take b is equal to 3. Then, by Euclid's algorithm, a should be equal to 6q plus r while q is greater or equal to 0. 0 is less or equal to r less than 3. If our remainder is 0, then a is equal to 3q. If our remainder is 1, then a is equal to 3q plus 1. If r is equal to 2, then a is equal to 3q plus 2. From above, thus it is clear that any positive integer is of the form 3q or 3q plus 1 or 3q plus 2 for some integer q. Show that n square minus 1 is divisible by 8 if n is an odd number. Solution. We know that any odd positive integer is of the form 4q plus 1 or 4q plus 3 for some integer q. So we have the following cases. Case first. When n is equal to 4q plus 1, then n square minus 1 is equal to 4q plus 1 ka whole square minus 1. Instead of n, we have to write down 4q plus 1. Here it's n square, then it becomes 4q plus 1 ka square. Now expand 4q plus 1 ka whole square, it becomes 16q square plus 8q plus 1 and minus 1 because a plus b ka whole square is equal to a square plus b square plus 2ab. Minus 1 and plus 1 will cancel. It remains 16q square plus 8q. Now take 8q as common. It becomes 8q into 2q plus 1, which implies that n square minus 1 is divisible by 8 because 8q into 2q plus 1 is divisible by 8 because 8 into q into 2q plus 1 are the multiples of 8. Case second. When n is equal to 4q plus 3, we have n square minus 1 is equal to 4q plus 3 ka whole square minus 1. Instead of n, here we have to write down 4q plus 3. In case first, it was 4q plus 1. Now, instead of n, we have to write down 4q plus 3. Now, expand 4q plus 3 ka whole square. It becomes 16q square plus 24q plus 9 minus 1. That is equal to 16q square plus 24q plus 9 minus 1 is equal to plus 8. Now, take 8 as common. It is equal to 8 into 2q ka square plus 3q plus 1, which implies that n square minus 1 is divisible by 8. Prove that the product of three consecutive positive integers is divisible by 6. Solution. Let n plus 1, and n plus 2 are three consecutive positive integers. What are consecutive positive integers? Back-to-back integers. Since any positive integer is of the form of 6q or 6q plus 1 or 6q plus 2 or 6q plus 3 or 6q plus 4, so on, 6q plus 5. If n is equal to 6q, then n into n plus 1 into n plus 2 is equal to 6q into 6q plus 1 into 6q plus 2. We have to replace n with 6q. That becomes 6 into q into 6q plus 1 into 6q plus 2. That is in the form of 6m, which is divisible by 6. If n is equal to 6q plus 1, then n into n plus 1 into n plus 2 is equal to 6q plus 1, 6q plus 2, and 6q plus 3. We have to replace the n with 6q plus 1. It becomes first multiple 6q plus 1 into 6q plus 2. When we multiple these two, it becomes 36q square plus 18q plus 2. Then into 6q plus 3. Now multiple these two. It becomes 216q square cube plus 108q square plus 12q plus 108q square plus 54q plus 6. Take 6 as common. Here it becomes 6 into 36q cube plus 18q square plus 2q plus 18q square plus 9q plus 1, which is equal to 6 into 36q square cube, 18q square plus 18q square, it becomes 36q square, 9q plus 2q, it becomes 11q plus 1. Now it is in the form of 6q, which is divisible by 6. Here m is equal to 36q cube plus 36q square plus 11q plus 1. It happens to the every case when you take n is equal to 6q plus 2 or 6q plus 3 or 6q plus 4 or 6q plus 5. Hence, the product of three consecutive positive integers is divisible by 6. Find the SCF of the following pair of numbers using Euclid's division lemma. First part is 75 and 243. Second one is 240 and 6552. Third one is 155 and 1385. And the last one is 100 and 190. First part, by Euclid's division lemma. Here A is 243 and B is 75. 243 is equal to 75 into 3 plus 18. Since our remainder is not equal to 0, apply division lemma on divisor of 75 and remainder 18. Then 75 is equal to 18 into 4 plus 3. Since our remainder is not equal to 0, apply division lemma on divisor of 18 and remainder 3. We have to apply the division lemma continuously till our remainder becomes 0. Here, now 18 is equal to 3 into 6 plus 0. Here, our remainder becomes 0. Therefore, SCF of 243 and 75 is equal to 3. Second part, it's 240 and 6552. Here, 6552 is A and 240 is a B. Then 6552 is equal to 40 into 27 plus 72. Here our remainder is not equal to 0. We have to apply the Euclid's division lemma on the divisor 240 and the remainder 72. Then 272 becomes 72 into 3 plus 24. Again, our remainder is not equal to 0. Apply division lemma on the divisor 72 and the remainder 24. 72 is equal to 24 into 3 plus 0. Therefore, SCF of 6552 and 240 is equal to 24. Third one, it's 155 and 1385. Here A is 1385 and B is 155. You have to apply Euclid's division lemma. Then 1385 is equal to 155 into 8 plus 145. Since remainder is not equal to 0, apply division lemma on divisor 155 and the remainder 145. Then 155 is equal to 145 into 1 plus 10. Since remainder is not equal to 0, apply divisor lemma on divisor 10 and remainder 5. 10 is equal to 5 into 2 plus 0. Hence, HCF of 1385 and 155 is equal to 5. The last part is 100 and 190. Use Euclid's division lemma. 190 becomes 100 into 1 plus remainder 90. Since remainder is not equal to 0, apply division lemma on the divisor 100 and remainder 90. 90 is equal to 90. 90 is equal to 10 into 9 plus 0. Therefore, HCF of 100 and 190 is equal to 10. Thank you. Have a nice day.